Section A, definition and examples. Example 1. Here we have g of x equaling the step function of x. So we have two differing limits from different sides. So the limit as x approaches 1 from the negative side equals 0, but the limit as x approaches 1 from the positive side equals 1. So that means that we do not have a limit at x equals 1. So the graph looks like this, where we have different limits at different integers. However, we can still find the limit at non-integers. For example, the limit of x approaching 0.6 of the step function of x equals 0, and the limit as x approaches negative 2.9 of the step function of x, as we go here, 2.9 is 3. Alright, so that basically explains limits in an example, and now we're going to example 7. So example 7, we're going to describe the limit as x approaches positive infinity and the limit as x approaches negative infinity. In order to find these, you have to look at the function's highest highest power. So we look at A. So we have f of x equals x cubed minus 3x squared plus 7x plus 2. Since x cubed is the highest power, it's an odd function, which means that if we look at the graph of x cubed over here, as it gets into the negative region, it approaches negative infinity, and as it goes into the positive region, it approaches positive infinity, as stated here. So the limit as x approaches positive infinity of f of x is positive infinity, as stated before, and the limit as x approaches negative infinity of f of x equals negative infinity. So that means as it gets closer and closer to negative infinity, then f of x will also naturally go closer and closer to negative infinity. Then we have one with an even function. Here we have f of x equals negative 4x to the 4th power plus 1 million x cubed plus 100. So we only care about the highest power, which in this case is x to the 4. Since x to the 4 is an even function, the directions will point the same way, and the negative sign tells us that the graph will look like this. So then the limit as x approaches infinity of f of x equals negative infinity, as shown by the graph, and the limit as x approaches negative infinity of f of x also equals negative infinity, as seen by the graph. And that is it for section A.